Hello students. So in this video we are going to cover chapter 12 of grade 12, chapter 10 of grade 12, haloalkanes and haloarenes. So in this video we are mainly going to cover name reactions. So that's going to be from this particular chapter. So first name reaction that we have in the chapter is Groove's process. Now this is a process where we use alcohol to prepare an alkyl halide. Let's see what the equation is. So for this equation, we need an alcohol plus HCl. Now this is going to be in the presence of an Lewis acid. So here we will have anhydrous ZnCl2. Now in this case, OH from here and hydrogen from here will combine together to give water. Cl being the negative center is going to bond with R, which is the positive center here, to give alkyl halide. So we have RCl. Now if you're taking an example for this, we can just substitute R group with a simple methyl or an ethyl grouping. So instead of R, I'm just taking say ethyl group. So I'll just take CH3, CH2 and the remaining OH will be there. Now this with HCl in the presence of anhydrous ZnCl2. Now here OH from here and hydrogen from here will move out as water. And then we have CH2, CH3, CH2 which will bond with negative center from here which is Cl to give ethyl chloride. Now the second process is Darzin's process. Now for this particular reaction, we are going to take alcohol ROH plus we need to take thionyl chloride SOCl2, and this is going to happen in the presence of pyridine. Now here R group being the positive center will pick up Cl which is a negative one to form alkyl halide. Then Cl2 will be here, that will combine, one of the Cl is going to combine with hydrogen to form HCl. And then SO plus the oxygen here will release SO2 gas. Now the same thing if I'm taking an example for it. You can again take R as any alkyl group. So here I'm taking again ethyl group, ethyl alcohol plus SOCl2 in the presence of pyridine. Now here same way, R group is CH3, CH2 with a Cl. So this is the positive center. This will pick up a Cl and form CH3, CH2, Cl. So one of the Cl has moved here. The other Cl here will pick up hydrogen and form HCl. SO and this oxygen will combine to give SO2. So this way, if you know how to combine these elements and form your product, your name reactions will become much more easier. Now the next name reaction is third one, Finkelstein reaction. Here you will take an alkyl halide. So in this case, your alkyl halide is on the reactant side, which means it is going to be a chemical property of an alkyl halide. So you have alkyl halide reacting with sodium iodide in the presence of acetone. In the presence of acetone. Now here it's only an exchange of halogen. The halogen that is there here moves to sodium, and the halogen that is here will move to R group. So here we will form the products Ri plus you're forming NaX. So here if you see your product is particularly forming an iodide. So this particular name reaction is for preparation of an iodide compound, an alkyl iodide. Now we're taking an example for this. So here R group I will just take it as CH3Cl. Instead of X I've taken a halogen. Instead of R group I've taken a CH3. Now this when I react it with sodium iodide and the medium is with respect to acetone. Here it is an interchange of an halogen. So Cl will go to Na and iodine comes to methyl group. So here I'll form methyl iodide plus sodium chloride. So basically this is an halogen exchange method. This reaction is a halogen exchange method. Now the next reaction is Schwartz reaction. That is another name reaction that we have. Schwartz reaction. Now in this case, we will take say a halide plus we are taking a AgF as our reactant. Now by exchange, this is again another halogen exchange method. Br will go to Ag and F will come to R group. So here this will be Rf plus AgBr. So here again, because halogen is getting exchanged, this is also a halogen exchange method. So both Finkelstein as well as Schwartz reaction are halogen exchange methods. Now apart from using AgF, other reagents that you can use are Hg2F2. You can also use cobalt fluoride, or you can use antimony fluoride. These are the other three reagents that you can use instead of silver fluoride. Now when you notice in all these four reagents that I've used here, what is one thing in common? The only one thing that is in common is the halogen. It is a fluorine element. So which means this particular method, Schwartz reaction, is only for preparation of alkyl fluorides. This also when you take an example for this, instead of an R group, I'm just going to put a methyl group. And I can just do simple reaction. Methyl will pick up fluorine and give methyl fluoride plus AgBr. So this way these two equations here are halogen exchange methods. Now moving on to the next one, which is Sandmeyer's reaction. Now in Sandmeyer's reaction, this is for an aromatic system. So these were all for alkyl systems. Now we're moving on to aromatic system. Now in this case, we have your starting material as benzene diazonium chloride. So we have N2 with a positive charge and a Cl minus. So this is a benzene diazonium chloride. This is going to react with cuprous chloride Cu2Cl2 in the presence of HCl. Now when this reacts, the entire group here goes out and Cl will be bonded here. So this is in a way where we can replace the aromatic bond with another group. Generally we can't do it by normal methods. So we always prepare a diazonium salt, and because nitrogen here carries a positive charge, this bond is weak and it can be broken easily. That's why when we want to replace this aromatic bond, we always prepare a benzene diazonium chloride, then we do the replacing. And nitrogen gas is released out. So this is how you prepare chlorobenzene from benzene diazonium chloride. Now the next one is Wood's reaction. Now for Wood's reaction, we will take two alkyl halide molecules. So I have one alkyl halide here with two sodium atoms plus another alkyl halide. Now this entire process is going to happen in the presence of dry ether. So here when you have a halide, two halides and two sodium atom, these are going to combine with each other to form sodium halide. So that's going to be one of our byproduct. Sodium halide, two of that. But what happens to the R groups? This R group is going to bond with this R group to give a higher alkane. So this is going to be Wood's reaction. So we'll take an example to show the explanation of this. So here, instead of R group, both the R groups, I'm just taking CH3. So here I'll take CH3, and instead of a halogen, I'm just taking Cl. Instead of X, I'm just taking Cl. Now, with two sodium and the same group I'm mentioning here, and dry ether. Now the same way how we did in the general equation, we can do here also. Sodium being a metal will pick up both the halogens, and this is going to form a byproduct NaCl, 2NaCl. This CH3 is going to bond with this CH3 to give ethane chain. So initially what did we start with? We started with methyl group, right? But where did we end up in? We ended up in ethane chain. So from methyl to ethane, you're moving to a higher alkane. So this is one of the methods of preparing a higher alkane from a lower alkane. Now, instead of having, say, methyl group here and methyl group here, I can also have a mixture. I can have methyl here and I can have ethyl here. So it's not necessary both the R groups have to be the same. One can be methyl, the other can be ethyl, but both have to be an alkyl chain only. So here you can just make a note, R should be alkyl group always. Alright, so now we will move on to the next one. Another variation of the same equation, and that's going to be Woods-Fittig reaction. Woods-Fittig reaction. Now in this case, you're going to write the same type of an equation. Your general equation is going to remain the same type except for one change. So we will write the alkyl halide here as same. Plus 2 sodium also will remain the same. The halogen will also remain same. Now what we are going to do is, instead of the other R group, I am just taking a benzene ring. So here when I take this benzene ring, this reaction will change to Woods-Fittig reaction. Now the medium here is also the same, it's dry ether. The procedure is again the same. You will have halogen here bonding with sodium to give NaX, 2NaX. What about the R groups? This R group will be bonded on the benzene ring. So I'll just draw the benzene ring with an R group on top. So here I'm trying to form an aromatic system with an R group on top. So say for example, I'm going to take, instead of R group, I'm taking CH3, same way, and then this benzene ring. Now, this will happen in the presence of dry ether. Here also it's going to be the same. Halogen with sodium is going to be bonded to each other and you're going to get 2NaCl. Plus, benzene is going to be bonded to the methyl group just like this. And you're going to get an aromatic compound, methyl benzene, or you can call this as common name toluene. Next, the last named reaction is another form of this, which is called as Fittig reaction. Now, in the Fittig reaction, we need a benzene with a halogen plus 2Na plus another benzene group with a halogen, and this is going to be in the presence of dry ether. Now same way here also, both the halogen is going to pick up Na and form 2NaX, and benzene rings are going to be bonded to each other to form a diphenyl. So here you're going to form a biphenyl like this with Fittig reaction. So you can see the differences between all three equations here. In the first one, you took both the R groups as an alkyl group. In the second one alkyl, one benzene. And the third type, you took both as aromatic system. So this way, these are some of your name reactions that are required for grade 12 from chapter 10, which is haloalkanes and haloarenes. I'll see you in the next video with another chapter of name reactions. I hope this is helpful to you all. Thank you.